Hello everyone. We are the People Location Tracking Analysis team, and my name is Hussein Al-Ramzi. I am excited to talk to you about our electrical engineering senior design project. In the beginning, in this brief introduction about our project, I would like to introduce my teammates, starting with our team leader Patrick and the members Fadl, Chance, Amanda, and Jonathan. With the prevalence of the COVID-19 virus in the United States, universities and other organizations are attempting to minimize the risk of transmission in order to provide a safe environment for their occupants. Several precautions have been implemented to assist the initiative, such as social distancing and mandatory face covering. The People Location Tracking Analysis team project purpose is to implement an inexpensive, effective, and non-invasive solution to track individuals in area for the purpose of increasing health and safety by reducing the risk of virus transmission through data collection and analysis. This goal is to be achieved by implementing computer vision and machine learning techniques. These techniques are implemented using edge in the field devices equipped with cameras and the processing power necessary to run calculations intensive algorithms. Now moving with our budget that we used with my teammate Fadl.
For the budget, as you can see, we have two pictures for the last semester and the current semester. And the additional is the AI kits, which valued $3,000. For the budget, UCD is 1,200, and what we use is $1,085. And for the camera mount, we designed and built a camera mounts to attach to the ceiling tiles and swivel in all directions. And now Amanda will talk about more about the project.
So we understand that upgrading an entire camera system can be expensive and cumbersome, so in order to work around that, we designed some mirror attachments to place next to existing lenses in order to utilize stereo system benefits, which included depth data and wider angle views. And the results can be seen over here to the right. And now John will talk about our wireless alert system.
The wireless alert system in our project was designed to interface with Jetson Nano within the camera module in order to provide a real-time feedback from the system. Specifically, our alert system has red and green LEDs which indicate if the room has reached its predetermined occupancy limit. This is accomplished using transmitter and receiver circuits which communicate 2 bits of data and turn on the corresponding LED located on the receiver circuit outside of the classroom. This allows a quick and intuitive way to determine the occupancy status of the room before entering. These are our Eagle schematics of the receiver and transmitter circuits with the 433 MHz modules and the HT12 encoder and decoder integrated circuits. These schematics were translated into a PCB layout and milled on campus in the electrical engineering lab manager's office. Next, Patrick will cover the use of Node-RED.
One of the biggest issues we faced when we were filming the ESL classrooms on the first floor was dealing with Wi-Fi connections and synchronous data, so our videos were not synced like they should have been. After consulting with Dan Connors, our student mentor, we ended up going with the Node-RED browser-based machine-to-machine communication tool. We use this to send a message to all of the Jetson Nanos in 2609 to tell them to record a video for a set amount of time. We also set it up to collect that data using a passwordless SFTP protocol and then send a message back to delete the recorded data. So this saved us storage space and then also kept all of our data in one place. Now Chance is going to go over our results.
In order to achieve the mapping that we wanted, we had to do a homography transform to create a new plane to map our transform points to. As you can see in these pictures, we drew over the lines in the maps that we created. So in the actual camera frames, those are the points that we picked to say where our plane would be. And then when we went over and found those same points on the floor plan image, we did a pixel per inch conversion to try and, as accurately as possible, find where those points were in the room and map them onto that. Then using this plane, we were able to take any of the centroid points that we got from our person detection program and map them onto the floor plan. Here's a result of what this looked like in the end. You can see the centroid is found, and then that centroid is being mapped, each dot over onto the map. So this is good for our foot traffic pattern. So none of the dots are released. You can see where people have walked the entire time. The top video is showing just a single person and how that does, and then the bottom video is showing what multiple people in a room being tracked would look like. And for this, after we were done with that, we analyzed the results to see how they looked. So between the two cameras, the green and blue, it showed the same general path of the person. However, we averaged the points together and found that it did create a more accurate path, which is something we'd want to pursue later for testing. Now Amanda will go over the 2609 results.
So the biggest difference between this room and 1402 is the size, which correlated to the number of cameras that we had to place in order to get a full view of the room. So as you can see in this bottom figure, each of those dot colors represents a different camera view, and red being the social distance violations being detected. And you can see that they accurately map out the general direction and path that each of the members is tracing in the room. And the biggest difference here is we also included a current position mapping. So you can see in this figure just those two camera views tracking the same person and just their current position in the room instead of the entire path that they have traced out. And then now John will talk about our acknowledgments.
We would like to extend our thanks to the CU Denver professors Dan Jensen, Jeff Selman, Dan Connors, as well as Chief Phibbs of the Aurora Police Department. We would also like to thank our sponsors from the Air Force Research Lab, Dr. John McIntyre and Dr. Felicia Harlow. Thank you for listening, and please see our final report for more detailed information.
What was the time? What was the